Here we have some sugar cubes. If we had small enough sugar cubes, we could build a pile that would look identical to the piles that we've seen, to any of the piles that we've seen. Now what we want to do is we want to ask what would happen to the sugar pile that we had earlier if the diameter doubled. How much sugar would we need to double the diameter of a pile? What would the ratio of the volumes of two piles be if one had double the diameter of the other? Imagine that the first pile was constructed of tiny cubes. What would happen if we doubled the diameter of the pile? Well, one thing, the pile would get twice as wide, wouldn't it? Now, to get twice as wide, we could add a cube here. So now we have a pile that's 2 cubes wide. We just doubled the amount of material in the pile, and all we did was we made it twice as wide. If we double the diameter, it's not going to double in just this direction, it's going to double back this way also. So we're going to have to add 2 more cubes. And now we've essentially doubled the diameter. Well, that takes care of the diameter. That is, if we start with a pile made up of little tiny cubes like this one, and if we expand each of those little tiny cubes into a cube of this size, and keep all the cubes where they are in relation to each other, the diameter is going to double. But that doesn't double the height, because we notice that the height also increases. So we're going to have to add 2 more cubes. And now we have a cube. It's not twice as big as the first, it's 8 times as big. Okay? Here's the first cube. Here's the second. This cube has twice the dimensions of this one, but it's obviously going to take 8 times as much sugar to make a cube that's twice the dimensions. So we see that if we wanted to make a cube 3 times the dimensions, we'd probably have to increase the width by a factor of 3, the depth by a factor of 3, and the height by a factor of 3. That would take the volume of the first cube and triple it, then triple it again, and triple that again. So if we triple, we got 3 times. If we triple that, we've got 9 times. If we triple that, we've got 27 times the volume. If we just triple the dimensions. If we quadruple the dimensions, then we're going to have 4 times the width, 4 times the depth, and 4 times the height. That's going to give us 64 times the volume. So this is a phenomenon we have to keep in mind as we think of what happens to the volume of a figure as we scale it up.